Hello everyone. This video serves to explain to you the idea of um, functions of trigonometry, in particular for any size of angle. So, talking about trigonometric ratios or trigonometric functions, we basically have learned the basic ones in the previous year when we're talking about only sine, cosine, or tangent for especially special angles, but of course you can find the value of different trigonometric ratios using calculators, right? Here on this part, I'll show you the one in radian. It's already compiled nicely in the table for the basic special angles. However, we know in the higher level, we will need to deal with, for example, sine 120 degrees, or in radian, we put it as sine 2/3 pi, or maybe let's say cos 135 degrees, or tangent, let's say 240 degrees, or let's say cos 330 degrees, and so on. Or even more than that. In the higher level, you will see even worse, maybe for example 390 degrees, and so on. So there are many things like that. So then we want to deal with like how should we approach things like this? How do we make sense of this by using the unit circle? So for the sake of the discussion, I'll stop the discussion only with using degrees, okay? And then you can of course always translate it into the idea of radian. So if let's say you're given a unit circle, so as the name of the unit circle means a circle with the radius of 1. So here, 1, -1, -1. So the uniqueness of unit circle is that and in this case, when we're talking about trigonometric ratio, is that you can take any random point on the circle, and then you can always create a right angle triangle, which is basically that's, if you recall, what we discussed in um, circle equation. So basically, circle equation comes from the idea of putting right angle triangle, and then you use Pythagoras theorem all the time, so you can get that circle equation, right? So this coordinates here, of course, we name it as xy, and the definition is the degree or the angle that we're using is always starting from the positive x-axis here, and then this is where the theta comes in. So I'll put it as, sorry, I'll put it in another color. So if, let's say this is a triangle, so this is the theta, but then it will be on this direction. So the common direction that we have or we use is always anti-clockwise or counterclockwise. And then because of that, this is the radius, right? So it's also 1. So if we see that in the case of cos theta, so using the basic trigonometric ratio, the cos theta is basically this will be the x, this will be the y, right? Or it means this is y, this is also x. The cos theta is ka, right? Adjacent, which is x over 1, which also implies x is cos theta. Similarly, if you were looking for sine theta, you will get y over 1, or y equals sine theta. In other words, if you look at these coordinates, the coordinates as xy can also be represented as coordinates of cos theta, sine theta. In other words, when we're talking about, let's say for example, cos 120 degrees, that actually means the x coordinate, right, of a point on a unit circle, right, when the rotation is 120 degrees from positive x-axis. In other words, cos 120 degrees will be, let's say, it will be somewhere here. So 120 degrees. So if I create a right angle triangle, so this number, that's the cos 120 degrees. So that's actually what it means. In other words, as an implication, so back then we know trigonometric ratio is only until 0 until 90, and then the value is always positive. So then here, then you will be able to tell, for example, like cos 120 degrees, the value is negative. and that makes it possible because the trigonometric ratio is no longer a ratio only, but it's also what it means by cos and sine is talking about the x and y coordinate also of a point, right? So that's something that you can look up in the Wolfram math alpha if you want to. So it's something they do explain it over there. So for example, for the sake of the example, let's see through different cases. This is the summary that later you will be able to need, and then you will use this as like quote unquote like a dictionary or Bible for doing dealing with trigonometric functions. So let's see, for example, let's make a copy for this, and then let's do it somewhere here. So if, for example, now what we are dealing with is, let's take a look over various values of, value of trigonometric function. For example, we're dealing with, let's say, sine 120 degrees. Okay, so what is basically sine 120 degrees? As our discussion earlier, so we should be able to tell that, sorry, this one, let me delete. Okay, sine 120 degrees, basically that means this is 90 degrees, right, coming from here. And let's say I'll take it somewhere here, and I'll create, this is basically 120 degrees, so 90 plus 30 degrees over here, and I can again create a right angle triangle over here, right? So then whenever you see this by the concept, dealing with sine 120 degrees, actually I'm dealing with the small right angle triangle. This is term 60, sorry, instead of 30, because the 30 is here, so the 30 will be here, right? The radius is 1. This is the y, this is the x again. So whenever you see sine 120 degrees, I'm talking about the y coordinate, right? The y coordinate of this point, right? Like this. So that means instead of using the sine 120 itself, instead I'm using the 60 degrees, interestingly. So in this case, dealing with that value, so I'll need to use sine 60 degrees, y over 1, so the y is sine 60 degrees, which is half root 3. However, since the case of sine 120 degrees is also in the quadrant 2, this is quadrant 2, by the way, quadrant 1, this is quadrant 3, this is quadrant 4, so the y is still positive as well, right? But then if you're talking about the x, it will be negative. So in this case, to write it in a more elegant manner, sine 120, instead of dealing with the 120 itself, what I will do is 180 minus 60, right? And then I will deal with the 60 itself, which is half root 3. But if let's say I'm dealing with cos value, so the cos 60 degrees, by using the previous summary that you see over here, in second quadrant, I'll be using this, or that's basically 180 minus theta, right? So in this case, instead, what I will need is cos 180, cos 60, it's not cos 60, it should be cos 120. Cos 120 degrees, it will be cos 180 minus 60. So then instead of using the 120, so I'll be dealing with the cos 60 itself. However, cos 120 is quadrant 2, which means the x must be negative, while the y is positive. So this instead will be negative, so negative half, something like that. So the similar idea you can deal with in quadrant 3, quadrant 4 by using this. I'll show you more examples in the next case, the next video, by using this unit circle again. Hopefully this helps at least for the quadrant 2.